Hello and welcome to today's webinar, The Impact of Fast Data for Personalization. I'm Peter Vescuso. I'm the CMO at VoltDB, and I'll be the host for today and also one of the speakers. And with that, I'd like to introduce Chris Wright, who's the co-founder and CTO of deltaDNA. Chris founded deltaDNA in 2010, serves as the Chief Technology Officer. His aim is to bring the sophisticated analytics and monetization tools of the financial sector to the games industry. And I think you'll see he's done a terrific job of accomplishing that. And he's done it with VoltDB. Previously, he was the European Director of Production and Publishing at iPlay, where it became a top 3 mobile games publisher worldwide, with relationships spanning Electronic Arts, Activision, EIDOS, Universal Pictures, MGM, and many others. And as I said before, I'm Peter Vescuso, CMO of VoltDB, excited to be with a company who's kind of on the cutting edge of what is possible with fast data and fast data applications. And this general use case of personalization is one of the most exciting, and I think you will see that as we go through. So I should have flipped. Here's a picture of Chris and myself, and we'll kick it off and we'll get started. I'm going to provide a little upfront context, generally talk about fast data and personalization, and then hand it over to Chris. There's a lot of discussion in the business world about big data. And I've mentioned fast data, and I wanted to give kind of our perspective on the difference between fast and big, because I think there is significant difference. Big data generally is data that's been collected, data at rest. And there's a lot of value in big data. There's a lot of investment to mine the value of big data. But fast data is different from big data and has different requirements, has different value, and also benefits from the knowledge and insights gained out of big data. But fast data is basically data in motion. And data is fast before it's big. It's typically flowing in real time and being used for different applications, and it has a different opportunity associated with it than big data. Mike Gualtieri, who's a principal analyst at Forrester, talks about fast data as containing perishable insights, and that those insights can have exponentially more value than after-the-fact traditional historical analytics. Chris Wright from deltaDNA is going to talk about that a lot. The insights that Chris and deltaDNA are able to generate and put into practice in real time have enormous business value, and they have figured out terrific ways to monetize that. So you'll see great examples of that. But the point here is that data is transforming business. A lot of the focus has been on big data, but fast data is a different and very valuable opportunity. And that's what we're talking about today. I said data is transforming business from a marketing perspective. And I'm going to talk generally in my introductory comments about marketing, customer engagement, and personalization. That's a very important topic and one that I know is being discussed out there a lot. But the way technology has changed is enabling huge advances in the way that marketing is done, customer engagement is done. And again, when we get to Chris and deltaDNA, the customer engagement and the personalization that they're able to accomplish is really cutting edge. But at a high level, and I think this is intuitive, technology has enabled us to move from doing marketing and customer engagement from general, broad content targeting to being able to target and talk to individuals and do it in a smarter, much more individualized way. And there's significant value in being able to do that. I think that makes sense intuitively. And again, Chris is going to talk about it specifically with respect to deltaDNA in gaming. But I think these principles apply whether you're in the gaming business or whether you're interacting with customers in other vertical industries. Forrester Research, they also talk about how digital is transforming the game of business. Now, their use of the word game here is coincidental, but I chose it intentionally because customer engagement and customer interaction with deltaDNA is literally a game. For the rest of us, it's a means to an end of having closer, tighter, personalized experiences. I think we know everything is going digital. People are living on their smartphones. Digital technology is rapidly advancing. Fast data technology is rapidly advancing and enabling new ways of having customers experience your company, your business, and the way that they engage with you. From that same report that I just referenced, Forrester talks about digital transformation, and some of the key takeaways from that survey and study that they did, asking about how digital will impact different areas, was digital disruption is having the biggest impact on marketing, on the customer company interaction, which marketing is responsible for. At VoltDB, we talk a lot about how data is transforming business, and at this intersection point, it's transforming it dramatically. Marketing success depends on having a competitive or a superior customer interaction and engagement. Personalization is a powerful tool for doing that, and I think this applies generally. And again, when we get to deltaDNA, and Chris, I think of deltaDNA and what Chris has been able to accomplish as being on the cutting edge, being the most expert in being able to engage and manage customer relationships in real time. And while he's going to talk about it specific to the gaming industry, I think the concepts and the technologies and their approach apply generally. So talking about being able to have a more competitive way of interacting with customers, we believe that in the future, all businesses are going to compete on their ability to make decisions in the moment with their customers, basically tapping into and being able to monetize fast data. We're talking a lot about personalization. At VoltDB, we tend to talk about hyper-personalization, being able to engage customers on a per-person, per-event basis and do it in a customized way, which is not something that has been easy to do in the past, but as I said before, technology advances and specifically VoltDB make that much more easy, practical to do today. And lots of examples in a lot of different industries. In the telecom and mobile space, contextual marketing, real-time offers, real-time user engagement is critically important. We've had other webinars where we've talked about that. Mobile and telco have always had an appreciation for being able to do things in real time, and that industry as a whole is very good at applying those techniques around their customers. Financial services is catching on rapidly. Being able to do personalized trade recommendations in real time based on a customer's preferences and what's happening in the market at the moment based on news, stock quotes, etc., is another great example. In the pharmaceuticals industry, being able to provide real-time contextual marketing for physicians that are searching for different types of drugs or answers is yet another example. In online gaming, I'm going to really leave that up to Chris, but I think you'll see that this is probably one of the best, most sophisticated, and from my perspective, one of the most interesting examples of hyper-personalization that I've ever seen. So VoltDB, where do we come in? I didn't talk a lot about what VoltDB is. I'm kind of assuming that you might know, but let me just say explicitly, VoltDB, we're a purpose-built OLTP platform for fast data. And we don't make applications, but we work hard to try to make applications faster, smarter, and simpler. Faster is just raw either transactional performance or response time, being able to do very high volume and velocity data ingestion, high transaction rates with millisecond response time. Smarter applications and applications that can provide real-time context and intelligence for richer interactions. deltaDNA is a great example of that. And simpler. We see customers many times trying to pull together a disparate number of components, open source and others, really, and try to build their own distributed data infrastructure. And our perspective is, hey, we've invested a ton in that. We think we have a world-class platform for that. Focus on your application and your business logic and leave that distributed data infrastructure to us. Quickly, just VoltDB, we talked about technology advances. VoltDB embraces really many of the latest technologies. 100% in-memory architecture, transactionally consistent, immediately consistent, never lose data, designed with a massively parallel scale-out architecture, designed for the cloud. We've got the connections to be able to ingest and export data rapidly. Chris is going to talk about using VoltDB actually in conjunction with other applications, and you'll see some of that. I mentioned before a transactionally consistent platform. Data is immediately consistent with VoltDB. There's no delays there, 100% accurate, and you never lose data. Plus, fully relational with both SQL and Java programming capability. So none of the compromises typical of NoSQL solutions with all of the benefits of high-performance scale-out architecture. Okay, and in terms of where we fit, a little positioning, this chart is showing on the left-hand side kind of the speed of response. How quickly do you need data? In big data applications, many of them, you don't need millisecond response time, but fast data applications you typically do. And then the horizontal axis is how important is the data? Is it high-value data where you really require 100% accurate, immediately consistent results or not? And shows that kind of in the lower left where system response time is not critical and immediately consistent transactional results are not important. There's a lot of solutions there. I'd say typified by Spark and Hadoop solutions. Lots of companies are using that for their big data needs, and that's really not exactly a fast data solution. Systems that need very fast response time are many times built off of stream processing solutions that include things like Apache Storm, and maybe with Cassandra. Cassandra is a NoSQL database. And in those applications, the importance of having immediately consistent 100% accurate data isn't quite there, and those solutions in many applications are just fine. But on the upper right-hand side, if you have apps where you need high performance, you need a consistent 100% accurate solution and can't afford to lose data, VoltDB really stands alone. And by the way, you're not compromising anything. You're not giving up anything that these other solutions offer. You're getting all the speed, scale, and performance that they offer with 100% data consistency and durability. Okay, so talked a lot about VoltDB, where we fit. This is the view looking at VoltDB in that flow, kind of the fast data pipeline, data streaming in from many different sources, VoltDB being used as a operational database performing live analytics with real-time operational interaction, and data eventually being exported out and saved in a long-term data store, be that Hadoop or other solutions. And you see the arrow on the top showing the feedback from the big data back to VoltDB that shows that many of the insights, models, predictive analytics that may be discovered and refined on the big data side get applied in real time with VoltDB. So VoltDB is operating on live operational data, whether those operations are trades in a financial service environment, messages, or data representing real-time gaming, doesn't matter. This same architecture applies in all those cases. Okay, and with that, I'm going to turn it over to Chris Wright of deltaDNA, and he'll give you a very specific example of how they've applied these concepts and approaches, and I think have really the best personalization solution on the planet. Chris.
Thanks, Peter. Hello. let me just give you a little bit of background about deltaDNA. So we are analytics and marketing personalization platform focused on the online games industry. We're completely self-service, so for clients, they can sign up to us from our website. They can download our SDKs that you plug into the games, send us data, and then you can access our platform, which is a web-based platform with large databases behind that drive our system. And we very much focus on the free-to-play space in online games. So just to give a little bit of kind of background to those people who don't necessarily fully understand the games industry and kind of the evolution of the industry, we've moved over the last 30, 35 years. We've moved through arcades where people would go up and directly spend money in an arcade machine, to computers, so your personal computer in the house, and then the console, and now to mobile. And the big change that's happened is this kind of concept where with computers and consoles, you would go out, you would spend $30, $40, $50 for your game, you would bring it home, and you would play it. And basically, you were paying for the game up front, so it was very much based on the license of the game, the marketing behind the game that would drive people to actually play the game. And then the actual playing of it, they didn't have any cost once they had bought both the console and the game. And to put it into context, there was about 100 to 150 million consoles sold in each of the generations. So when you look at PlayStation 1 or PlayStation 2, PlayStation 3, those generations of consoles, there's about 100 to 150 million consoles sold. So about that number of people were buying and playing games. So a really successful game would sell maybe 10 to 15 million copies. And from a game publisher and game developer perspective, it didn't really matter how much the person played the game once they'd spent that $50. They would go out, they would buy the game, they would put it into their console, and they would play it. But they'd already spent the money, so if they played it, that was generally a good thing, because they might buy the follow-up to the game. So you didn't necessarily want them to play it too much, because you'd want to then sell FIFA 2014, 2015, etc. But ultimately, and from the games industry's perspective, we thought that everybody would buy our games. They loved them. They played them hugely, and then they waited for our follow-up, and they would go and buy that. Now, what happened is this industry started the early 2000s, specifically over in Asia and Korea, and has really hit the European and the West market in the last 5 or 6 years, really since the iPhone launched and apps launched on the iPhone, kind of the end of about 2008, 2009. And what that did was, firstly, it massively expanded the number of people who play games. So suddenly you didn't have to go out and spend $300 to $400 on a console. You had a phone in your pocket that you could play games on. So suddenly our target audience was massively larger. It wasn't 100 million or 200 million players, but it was billions of players. And the second thing that happened was the likelihood of those people spending $40 to $50 on a game was very small, so we looked at new models. And the free-to-play model, which is where you download, bring the game onto your device for free, and then you play it. And as you play it, you are given the opportunity to spend money. And that opportunity might be to buy extra lives, it might be to progress quicker, it might simply be to better personalize the game, so buy cats or things for your characters. But basically giving our players lots of opportunities to spend money in the game whilst not trying to stop them. And what that did to the mechanics was suddenly we had not 5 or 10 million players playing a game, but we had 50 to 100 to even 1 billion players playing these games. So huge numbers of players playing games, but only a very small percentage of those players would ever actually spend any money. And it has become a needle in a haystack. 1 to 2% of the people who play these games will actually spend what's called in-app purchase, IAPs, so go and actually buy some bullets or some extra lives for 99 cents or for $2.99. And what we also found was that a lot of players didn't continue to play. So the retention of playing these games was a lot lower than we expected as an industry. So where we thought everybody played our games and loved them, what we actually found was quite often half of the players wouldn't even get past session one. So the opportunity to play games is massively broadened. The attention span of players has reduced, especially as we've just widened the demographic of the players. And the way we are actually monetizing those games has completely revolutionized. So we're now trying to find interesting ways of encouraging people to spend money whilst they play the game and keeping them retained, keeping them enjoying that experience whilst putting up opportunities to spend. So that's where we sit. And deltaDNA was really created and started fundamentally on the idea that this was a whole new market. There was incredible need for better analytics, for understanding of the players, what drove those players to retain and drove those players to spend, and that the traditional analytics tools that were really web-based just were not up to it. They simply didn't have the capability to understand the players. They weren't designed around the devices that players were going to do. The games themselves are fundamentally different kind of application from a more traditional web application, and that we needed to be able to react to players much quicker because we had such a short period of time whilst we had them interacting with the application, the game, to actually make offers and incentives, and we had to try and figure that out very quickly and make those changes. So this is the space that we started on, and we've been building the technology over the last 5 years. So the evolution of analytics, and it's very much that move from dashboards, so the kind of traditional BI where you want to be able to understand what's happening in your game. You want to be able to understand what people are doing, why they're doing it, and actually taking that a step forward and starting to look at predictive modeling to be able to not simply understand what they're doing now, but understand what they will do in the future. So deep analytics, the ability to really understand your players, segment your players into a whole set of different kinds of player behaviors, predict those player behaviors, and then ultimately to actually action that. And I think that's really important. It's really important that you're not simply trying to get an understanding and identify players, but actually try and personalize that experience to individual players so that you are actually making the experience different. And this is extremely important in games because games there is no need to play a game. They're not doing it because they're going to buy a new hat or whatever it is. They're doing it because they want enjoyment, and therefore the game has to be an enjoyable experience. And so a single one-size-fits-all just doesn't work in games. It needs to be something much more personalized. It needs to fit to how the player is actually playing the game. So talking about some of the kind of common monetization strategies in games. And as I said, we take the middle one to start with. There's in-app purchase, the idea, and this is the core way that games monetize. Somewhere between 50 and 70% of the revenue for a free-to-play game will be in-app purchases. Players buying boosters, buying more content, buying lives, a mixture of buying and then earning as well. So there's a combination in these games where you'll have a paid-for currency where you buy that currency and use it to buy things in the game, and what's called a grind currency, a currency which you earn by playing in the game. And then you can use that to also buy things. So the combination that you are not ever locked out of the game, you can continue to progress, but you either need to earn that within the game experience, you need to win races, or you need to actually go and spend money. And the best types of games, the ones where this works very well, is where you combine the two. So by actually earning currency, by maybe winning races, if you buy a better car, you get to win more races, you get to earn more currency, and there's a nice virtuous loop around that. On the left, a lot of games are now using ads as a core monetization strategy. Not simply to have ads kind of interstitials stuck into the game where as you play it, it sticks up an ad, but actually build them into the reward mechanics. So you get the opportunity to either spend money, or I can actually buy some premium currency, or I can get a better car by watching an ad. And these are called rewarded ads. So what you'll do is it'll give you the offer, and it'll say, okay, there's an opportunity to actually to earn some of the currency by watching ads, and you can then earn extra lives or entrance to tournaments. And so ads are now becoming a really important way of monetizing the 98% of users that won't spend real money in an app purchase. So if 2% of our players will actually spend, you can monetize the other side of the a much larger percentage of users. And also it's used as a ramping system to allow people to start to understand what the opportunity and the advantage of actually spending money. So they can earn some premium currency, they can then buy some items, they can get a feel for the advantage of doing that, and then actually we'll find users who will do a combination of both. They'll both spend money in our purchases, and they'll also actually use rewarded ads to top up that premium currency, and mix and match both. And then retention. Ultimately, the core of all this is retention, keeping the players playing, which is very simple. If people don't play the game, then they're not going to spend money. So you have to make sure that the game it has to be enjoyable, it has to be fun and exciting, and it has to be addictive. And there's lots of mechanics, not just around pure kind of core gameplay, but things like daily tasks, things that drag you back, things that try and remind you that there's a reason why you should actually click on that icon on your iPhone. If I come back tomorrow, then I can earn some premium currency. There's competitions, especially where you try and combine social networks, so you can see all your friends, and then you can compete in kind of mini tournaments with your other friends. You can do online gameplay with Hearthstone does actually playing not just the computer, but you're actually playing real people. And that ability to involve yourself within the community. And there's also a lot of work done on regular content and updates. So, with these games, what we've done in games is we've turned a product, a reasonably high cost commercial consumer product, into a ongoing service, something where players will keep spending money as a part of the experience, but they expect the game to evolve, they expect it to change, they expect new content to come out, and they want that continual feeling of regular content updates. So some of the kind of common monetization issues which every games developer hits when they're trying to build a free-to-play game. And it's got to be really important to kind of stress that this is still extremely early. We've only really been building these games for the last 5 years. So we're still learning how do you best build free-to-play games, what mechanics work, how do you try and personalize this back down to the user. The problems that we find with the developers we work with, small number of payers, the percentage of spenders is extremely small, 1-2%. And so being able to not just identify those users and encourage and keep them playing, because they're obviously extremely valuable, but how do you actually expand that? What you don't want to do is build a system, a game that is just trying to milk your whales. What you want to do is a way of trying to expand the number of people who spend, even if it's a small amount, because we know from the analytics that once somebody spends once, they are much more committed, engaged in the game experience, and they're much more willing to keep playing, to invite their friends, and to potentially spend again. So it's really important to get over that initial barrier. That first from a non-payer to a payer is the big barrier that is the holy grail of free-to-play games. How do you get people to do that? Retention, keeping players playing. So beyond session 1, keep them playing for session 2 and session 3, because we see that quite often 40% and even worse, more people will leave on that first session. So actually, how do we make the experience enjoyable, and how do we make sure that once they leave that first session, they come back for session 2? And with this, what you're trying to do is mix both a retention strategy to keep people playing, so making the game enjoyable and easy and fun and rewarding, with an in-app purchase strategy for actually making sure that you are putting things out so that people can actually spend money, and have the opportunity and actually get good rewards from when they do spend money. And then an ad strategy, which is all about making sure that you can use ads to monetize those users that won't spend money, that you can use ads as a rewarding mechanism so that they can actually watch ads and then they can gain some in-app purchase gold or premium currency, and that they feel that this is a combination. So it's not simply showing ads to non-spenders and getting the spenders to spend money. You actually want to combine these two things in a sensible way. And so what you have is quite a complex environment in which you're trying to balance a whole set of different things whilst the players are playing, trying to identify those players, trying to keep them playing, trying to make sure you make the right offer at the right time and at the right price, and you're also trying to mix showing ads, encouraging people to interact with rewarded ads, putting up offers, and doing this in a sensible and consistent and coherent way. So what we've done at deltaDNA and what we've tried to do is try and bring all of this data together. The first thing you need is you need really rich data. You need to be able to collect data, in-app data, so what are the players doing, when are they interacting, what are they buying, the in-app purchase, the item purchase data, about what they're actually spending money on. You also want to have demographic data, both about the device, what's the device that they're playing on, because that will actually quite often fall into demographics. So, expensive devices has an impact on the likelihood of those players spending money, and other demographic and geolocation data, so you can start to better understand the player who's playing as well as what they're doing, and then ad data. So what are they looking at? What ads are being shown? How are they interacting with those ads? What is the revenue coming back from those ads? So that you can pull all this together and you can actually really understand what your players are doing at every point in the game. Every second as they play the game, you have a really good picture of the player. So you can start to make these intelligent decisions. And we see this as a marketplace, really, as an integrated approach. So we see ads, in-app purchase, and retention, and we look at the whole thing. It's really important to look at the whole economy. I think over the last few years, games they've either looked very simply at in-app purchase behavior, so, I see this person spending, so I'll try and get them to spend some more. Starting to maybe look at some behavioral information, but the data that's often collected for behavioral information is very aggregated, so a lot of the analytics tools simply don't let you get down to the detail. And then ad data, which is fragmented across a large number of different ad networks. And so you can't pull this data into one place. You can't get it down to the user. Quite often you'll find that the data is always aggregated at different levels. You might know exactly who spent money. You might know some aggregated data about what they're doing in the game, and then you might have some day-aggregated data on how much money is being spent on ads. And you can't pull that together into a single place, and you can't bring it down to the user level. So what we've been doing is making a system that allows us to bring everything down in real time to the user, so we know exactly what they're doing, what they're spending, what ads they're watching, and how much revenue that is generating, so that we can make these intelligent decisions at the player level. So it's really important that you make those individual decisions. And I think this flows on to what Peter was saying about kind of going from the aggregated view, which is very much where analytics was, to actually making personalized specific decisions on specific players at the point in which they're playing. It's no good in a game to simply say, you know what, I think I've identified a group of users and I will contact them by email or I'll contact them after the effect. You actually have to catch them whilst they're playing the game, because if you don't, the chances are you'll never see them again. They will simply leave the game and they won't come back. So unless you can actually make that intelligent interaction at the point in the game experience, then you basically lost that opportunity. And notifications, ways of trying to pull users back it's one aspect of this, but it's shown to be very poor. The chances of people actually picking up on a notification and being driven back into the game is very low relative to actually that in-game experience. So it's all about being able to understand the players. And at deltaDNA, we do two things. So we see the we see the technology in two halves, and there's a nice kind of tech diagram at the end of this, which actually shows this quite nicely, which I'll get to in a couple of slides' time. But fundamentally, we have two sides of the system. One is all about being able to do very fast data analysis and data mining, the ability to get all of these billions of data points that we collect from these millions of players, putting them into a system and being able to do clever analytics, being able to do funnel analysis, user analysis, data mining, running predictive models on those players, and really understand your players and being able to do that very quickly. So your queries and analysis isn't taking hours or days, it's taking seconds or minutes. So the ability to actually analyze the data at the speed of thought. And that's really important because you want to be able to try things out. You want to say, well, you know what, I want to understand what these players are doing, what segment of players is really important to me, who are the spenders and who are not the spenders. So that ability to do very fast analysis on this very, very large, huge data set is incredibly important. And then the other side of this is then being able to interact with those players at exactly the right point in the game with exactly the right offer. And to do that, you need very fast, real-time analytics that then, and you want to be able to join those two things together. So that's what we've done at deltaDNA. We built a platform that actually allows us to do both of those two things, and the two things work together in a way that I don't think any other platform actually managed to deliver. So it's very important that we are doing both this fast data mining and this real-time in-game personalization. And this is we have a whole set of these, and if you come to some of our kind of presentations we did one at GDC fairly recently, you'll see slides like this. But this is something that we talk about a lot, which is all about the flow of the player. And what I mean by flow is that when a player gets in and starts playing a game, there is your gameplay is there to balance between boredom and anxiety, kind of easy and hard. If the game is too easy, the player gets bored. If they get bored, they leave the game. If the game is too hard, it'll become frustrating. They don't feel that it's the game. It feels that they don't feel it's them. It feels it's the game. It's stopping them from progress. They get anxious. They get annoyed with the game, and they leave. And so the core objective with any game is to try and keep the player within these two levels, and that's called flow. And if you can do that, and the games that are the best, the most addictive, are the ones that actually manage to balance players between these two levels. Now, obviously, that's a very difficult thing to do for the general, but it's much easier to do on the personal level. So by being able to predict what the player behavior is like, and you can do this relatively easily, especially with our platform, you can start to take that data and you can pick how competent that player is, what their likelihood of spending is, what their likelihood of retaining is, and using those predictive models to basically put them into a structure that allows you to then make different kinds of offers. So in this example, this is a novice strategy that we use, which is where we start to see the player coming in, we start to see them failing missions, we start to see their anxiety becoming higher, that they're getting stuck. We have identified them in this example as a novice player. So what we're doing, therefore, is we're making offers. We're gifting them, not trying to get them to spend any money, but we're trying to get them to keep playing. So gifting them boosters in this example, which will hopefully help them get further into the game. You can see that the game begins to get a bit easier. We can do some interesting things with the actual game mechanics as well, actually dial down the difficulty, make the game actually easier as well as rewarding them. And doing the two of those things can be very positive because the player gets a good experience from being rewarded, but they also get the fact that the game is slightly easier that helps them get further. And then as the game starts to get slightly more difficult again, we can use rewarded ads and identify exactly the right point to actually give them those opportunities to buy more boosters, but to do it through a monetization strategy rather than simply gifting them. So this is a really good way of actually monitoring the player behavior and then actually changing and interacting with them. And we have a very powerful campaign system that allows us to do this. So what you're doing is you're creating campaigns, you're building the strategies in our data mining side, and then you can build campaigns. You can identify the player through the segments. You can identify what the player is going to do, and then you can make those offers. And what's nice about this system is that we can do this without the game having to be resubmitted. So it's all real time and it's all run remotely. So our clients can use our platform to actually build campaigns, build different offers, try different things, run A/B testing, and then push those into the game, see the effects, analyze what happens, and then iterate without having to bring the game down, without having to change the game code, submitting to Apple, which can take 2 weeks. So we can do this all completely remotely, and we can do this all through the platform, and we're doing it all based on the data that is flowing out of the platform, and then using that to make those intelligent decisions. So we're kind of wrapping the whole thing around. We're doing the analysis, we're making the decisions, we're implementing those within our campaign management and our real-time engagement system, and then we're visualizing the responses back through our data mining tools and our BI to see what the effect is in actually going around that loop. So being able to combine these things is really powerful. So as this is a tech kind of call, I thought I'd end up with a kind of a little look at, in a very high level, of course, the technology that sits behind deltaDNA. So if you look at this from the two sides, and it's very clear that what we do, so we have slightly more complicated than this, but in this kind of core example, we have two core big data clusters, database clusters that we use to drive our analytics. We use on the right side, and I'll start there. The right side is where our game developers are using our platform to do the data mining. And they use a Vertica. We use Vertica as our database cluster to drive the analytics. So all our data ends up in this very powerful data warehouse, and then we use a set of tools that allows them to run models against them, access that data, build BI reporting, and do the whole kind of analysis side of it and setup side of it, and the reporting back from the campaign management. On the left-hand side is where we have a real-time system. So the game itself is interacting. It's got SDKs built into it. It's sending us data events that keeps our system and informs our platform exactly what's going on. And that data flows initially through our data collection system, through Vault, and then into Vertica. So it ends in REST on the data warehouse, but all the way through this, Vault is actually ingesting, doing the complex manipulation, and then passing that data back down to Vertica to do the analysis, but using those metrics in that ingestion process to be able to make those decisions. Engage is our real-time interactive side of this. So with Engage, the game itself will call down at certain points the things we call decision points and say, I have a player at a certain point in the game. Is there something I want to do to that player? Do I want to show them an ad? Do I want to make them an offer? Do I want to change the experience? How do I want to interact with this user? That comes down. Within milliseconds, we make those decisions within Vault, and then we push the result back up that gets presented to the user. So that allows us to make those decisions exactly at the right point. The player has just gone through a level. They've just failed. They just got beaten by the dragon. We now want to actually decide what are we going to do. And what we can do in that is we can actually make intelligent decisions. So we can say, okay, for this user, we know that they're a spender. We know that they're likely to spend money. So let's put an offer up. Let's give them a 50% discount on a sword that will help them to actually beat this dragon. But for this other user, we know they're not likely to spend. So rather than actually trying to put something up in front of them that they wouldn't ever take on, we'll actually use our smart ads technology to actually put an ad in front of them, a rewarded ad that allows them to buy some in-game currency. They could buy something that will help them get beyond. It probably won't be quite as successful and as useful as the sword, but it'll allow them to progress. It'll give them a good experience, and it'll allow them to get a bit further into the game, and we can also monetize that user. So we can make those decisions, and we can actually make them based on the data that flows through at exactly that point. So this is where Vault and the real-time system comes in, and the ability to combine these two things and use the power and the analytics that we do in the Vertica side to drive the decisions that we can only do in Vault because of the speed and the performance that we need to capture those users as they play the game. So to kind of give a few takeaways out of this, and hopefully some of this was interesting, this is all really about interrogating data at the speed of thought. So we need to be able to get that data and make analysis decisions. We then need to be able to real-time interact with the users whilst they're engaging with the game. It's no good looking at players after the fact. It's no good sending them an email or a notification. Those are backup things, and we can always use them to try and drag people back into the game. But the most important thing about games is to capture them at the point in the game when they are actually playing, because that's the point they are involved in the experience and they're most likely to do something. And that's where they'll make their decision if they want to come back to the game, if they're enjoying the experience, if they're getting into the flow, and if the gameplay is fun and they're getting a good experience, then they will come back. So catching those players before they churn is so important, and that can only really be done with this kind of hyper-personalization, the ability to do it at exactly the right time. And we've got some great case studies, and I do push you to go and look at our website. We've got some great case studies with a lot of our clients on how we've managed to maximize and increase profit by up to 300%, how we've managed to better target ads, how we've better built engagement strategies. And we did a really good talk recently at GDC with one of our clients and actually showed a lot of this kind of flowing through, and they actually walked through the actual example. So there's some really interesting experience, and I think this really kind of proves and shows how if you do this kind of very fast interactive personalization, then you can actually make some real changes to the experience and push your profits up. So I think that's me finished. I'll just hand back to Peter.
Thank you, Chris. That was terrific. We're going to wrap up and do questions. Just a summary from Volt's perspective, we're working with companies like deltaDNA to make their applications faster, smarter, and simpler. I think deltaDNA and Chris are a great testimonial to what you can do with VoltDB. We wanted to ask two quick questions of our audience. One, was the webinar helpful? If you wouldn't mind taking a moment and just clicking on your response. And a second question, did you hear what you expected to hear, or are there other topics you wanted to learn about? We'd appreciate your feedback on that. Okay, let people finish that, and we'll move on to questions. You can use the chat window to type in your questions. As I mentioned before, if you want to try out VoltDB, you click on the download link, and we'd encourage you to check out deltaDNA's website and some of the use cases that Chris was talking about. Okay, Chris. So a couple of questions for you, Chris. You talked about, well, first I wanted to just say thanks. That was a great presentation. I was talking about Mike Gualtieri, the Forrester analyst at the beginning of the report, talking in general about the opportunity in fast data and the ability to capture perishable insights. And your example of that is absolutely perfect. You talked about, there's no good looking at a player after the fact. You've got to monetize it and react in real time. So if that isn't perishable, I don't know what is. So there were a couple of questions. You mentioned along your presentation, Chris, that you look at the balance between boredom and anxiety. One question was, how do you measure a player's anxiety? That's
a very good question. I mean, we look at a bunch of things. So we have some models that look at, so one example is we look at retention. So we have some predictive models that looks at the likelihood of those players to come back. So part of that is obviously by doing that, you're identifying some of the anxiety things. You're looking at aspects of the player behavior. You're looking at the likelihood of them failing. So, in the example we had there, the repeat failures of missions, the fact that they may get confused, the fact that they may get consistently beaten by a creature. So there are a set of, the skill with these things is to try and mix or split out the specific, and there's always going to be specific stuff in a game where you can identify, a specific problem. Getting lost is another anxiety, especially in a kind of a 3D experience. And the kind of more general things where you have some ideas of how long you expect a level to last. You can build some good models out of these things, and then you can start to see the differences and where you start to get 2 times standard deviation, you can start to see that actually players are spending too long in a level. They're getting stuck at certain points. They're not progressing as far as you would expect them to do. So you are laying on. I mean, anxiety it's a nice term. It's really trying to identify players that are doing things out of the ordinary from the kind of the standard way you would expect the experience to, and are either kind of repeating, or they're getting stuck, or they're not progressing as quickly as you would expect.
Yeah, that's fantastic. Makes me wonder if you have psychologists on staff there, Chris, that you consult with about this stuff.
Well, we have we have a great gameplay designer. Actually, we do game design as well. And what we found very early on was it wasn't just a case of being able to give kind of straight statistics back, but actually it's really important to kind of put this within the game context. So actually, we are looking at, not quite psychologists, but actually looking at the gameplay experience as well as the underlying data.
Yeah, that's terrific. Question was, so you talked about managing users in real time. Could you talk about some of the, the metrics, the numbers around how many users, how many, just give people some feel for the numbers around that, how many attributes or inputs you might be looking at? Nothing proprietary, but just generally.
Yeah, sure. So let me try and give you some kind of general numbers. The key to this is that these games have lots and lots of players. A small to mid-size free-to-play game will easily have 100 million. No, sorry, that would be a bit high. 1 million monthly active users. Really successful games will have 20 to 30 million monthly active users. And if you go to things like Candy Crush, I think they're looking at about 100 million. Now, to put that into context of how many users that is per day, it's roughly 10%. So a game that has 10 million monthly active users will generally see on each day about 1 million players. And so 1 million players, you're going to be seeing certainly tens of thousands at any one time within the game experience. So you're dealing with a lot of simultaneous players actually interacting with the game. And we certainly see, we deal with billions of data points on a daily basis, which means that we're certainly dealing with tens of thousands of simultaneous players hitting our system. As far as metrics, what we're actually making decisions on, we collect, the whole point of this is to collect very rich data. So though it's fairly game specific, I mean, we see probably the biggest games we'll be collecting in the region of 1,000 to 2,000 separate metrics per player. So they will collect a large amount of different pieces of data from, what mission are they playing, how much gold have they got, what was the last thing they did, what's the last item they bought, how often do they do certain things. So we're building a lot of these metrics, and we're certainly dealing with, I would say on average, probably about 500 to 600, and we've got some games that are dealing with 1,000 to 1,500 metrics. So you're making relatively complex decisions based on quite a large number of metrics. And you're doing that, you have to do this within certainly sub 50 milliseconds. You've got the internet delay in this as well, so you need to take that into account. So the actual time you have to process that decision is very short. And you have the same sorts of things. The tech that we use at the back end is very similar to what the ad networks are doing there. Again, making those decisions in real time. So the ability to try and make a behavioral decision in real time and decide exactly what you're going to do, you need to do that in certainly 50 to 100 milliseconds, that sort of time frame. And you have latency involved.
Yeah. Wow, that's really impressive. Certainly, that's got to blow away any other kind of real-time personalized application in financial services, retail, et cetera, et cetera, et cetera. Those kinds of numbers, that level of sophistication. When you showed your architectural diagram, a question came up about, is there any kind of dynamic, machine-to-machine learning going on between the Vertica system and the VoltDB system, or is that more done on a kind of more of a daily turnaround basis?
It's mostly done more batch in Vertica. We will push changes back into Volt, and we'll certainly make those decisions, but actually building the machine learning, we do a whole set of machine learning processes which we run on Vertica, and we'll build out the kind of the segments and the metric definitions, and we push those back into into Volt. And Volt always has, the way this works is Volt always has the absolute real-time view of the world. Vertica kind of has a slightly more batch view of the world, so we push data back into Vertica, and then Vertica does a lot of processing. It makes decisions on that, pushes that back, and then Volt actually makes the actual kind of, does this user fit the criteria? So the general kind of who should meet this criteria, who do we think is likely? So take an example of a spender or somebody who we think is going to spend. We build a whole set of models that try and identify that, and then we push that, and then Volt is actually making those real-time decisions, trying to fit each specific user into, do they meet that model as the player plays through the game.
Terrific. Thanks very much. So that was the last question, and we're really out of time. I want to thank all of our attendees, and especially want to thank Chris Wright and deltaDNA for participating. We'll follow up with everyone, and you'll get an email from us with a link to the recording and a copy of the slides. So with that, thank you, Chris. Thank you to our attendees, and we'll say goodbye.